Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find me at smarturl.it/Jedi. You can find information about me there. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you like these exercises, please consider making a tax-deductible donation to support our students at smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. A device contains two circuits. The second circuit is a backup for the first, so the second is used only when the first has failed. The device fails when and only when the second circuit fails. Let x and y be the times at which the first and second circuits fail, respectively. X and y have joint probability density function f of xy equal to 6 e to the minus x times e to the minus y for 0 less than x less than y less than infinity, and 0 otherwise. What is the expected time at which the device fails? Note that the condition for the joint density function being positive was 0 less than x less than y. Only for x and y meeting this condition we have positive density. Therefore, the marginal density of y is calculated as, well, it's f sub y of y. It's the integral from 0 to y over all possible values of x. So from 0 to y, x runs from 0 to y, of the joint density, which is 6 e to the minus x times e to the minus 2y dx. We taking the integral over all values of x of the joint density with respect to x. Of course, 6 e to the minus 2y is not a function of x, it's just the integral from 6 e to the minus 2y times the integral from 0 to y of e to the minus x dx. And this integral, if we calculate it, it would be minus e to the minus x, evaluated from 0 to y, and that's going to be, at 0, it's e to the, minus e to the minus 0, so just 1, and at y, the value would be minus e to the minus y. So if we multiply 6 e to the minus 2y times e to minus e to the minus y, we get minus 6 e to the minus 2y times e to the minus y. And then 6 e to the minus 2y multiplied by 1 is 6 e to the minus 2y. And then we multiply it out and arrange the positive term, the coefficient term first, the negative 1 second. So this becomes 6 e to the minus 2y minus 6 e to the minus 3y for positive values of y. And we're supposed to find the expected value of y. That's just the integral of the density times y. So integral from 0 to plus infinity of y times f sub y of y dy. So the integral from 0 to plus infinity of 6y e to the minus 2y minus 6y e to the minus 3y dy. Okay, so we factor out 6 over 2 from the first part, and then inside we would have integral from 0 to plus infinity of y times 2 e to the minus 2y dy. That's actually mean of an exponential random variable with hazard rate 2. Minus 6 over 3 times integral from 0 to plus infinity of y times e to the times 3 e to the minus 3y dy, and that is mean of an exponential random variable with hazard rate 3. And of course, the first mean is 1/2, the second one is 1/3. So this is 6 over 2 times 1/2 minus 6 over 3 times 1/3. Okay, well that's the same as 3/2 minus 2/3, which is 5/6, which is approximately 0.83, and that's answer D. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.